we are going to explain differentiation. Differentiation is continuation of differentiation of the C3. We are going to take differentiation of new types. We are going to have, the first type is parametric equations. Parametric equations. We know that parametric equation is when we are given x and y in terms of a parameter. For example, x was a function of t and y was another function of t. And we wanted to find dy by dx. We are going to get dy by dx by saying this dy by dx equal dy by dt times dt over dx, which means dy by dx by dt over dx by dt. Example. We are given x equal t cubed plus t and y equal t squared plus 1. So we get what is dx by dt equals 3t squared plus 1 and dy by dt equal 2t. Therefore, dy by dx equal 2t over 3t squared plus 1. We're going to have the next example. It says find the equation of the normal. Find equation of normal to the curve x equals sine theta and y equal x equals 3 sine theta and y equal 5 cosine theta at a point where theta equal pi over 6. What we are going to do is first we find the coordinates of the points when theta equal pi over 6. If theta equal pi over 6, what is x equal? 3 sine pi over 6, which is 3 times half 3 over 2. And y equal 5 cosine pi over 6, which means y equal 5 times root 3 over 2. We got the value of x and we got the values of y. Now we want to get differentiation. What is dx by d theta? Equals 3 cosine theta. And what is dy by d theta? Dy by d theta equal negative 5 sine theta. then we can get dy by dx. Therefore, dy by dx equal to, right, -5 sine theta divided by 3 cosine theta. -5/3 tan theta. At this point, therefore, it is -5/3, okay, tan pi/6, which is give us -5/3, -5/3 times tan pi/6 is √3/3. Therefore, the answer is -5√3/9. Yeah, but what is the gradient of normal? Gradient of normal equal 9/5√3 times √3/3. Therefore, it is going to be 9/3, 3/5√3. This is the gradient. But what is the equation of normal? Y minus the value of y we got in the previous page, and y is 5√3/2. 5√3/2 equal the gradient is 3/5√3 times x minus 3/2. Let us multiply the whole equation by 10. But 10y minus 25√3 equal. Multiply here by 10. This would be 6√3 x minus 9√3. This would be 10y equals 6√3x plus 16√3. Divide by 2, you have 5y equal 3√3x plus 8√3. This is the equation of the normal. Now we are going to go into the another type which is what we call implicit equations. Implicit equations. Implicit equations were the equations which we cannot write y subject. X and y are implied together. Like this equation, x squared plus y squared equal 8x. Or like the equation cosine x plus y equals sine y. We cannot write y subject. This is called implicit equation. How are we going to do it? We are going to do it by differentiating each term separately. Therefore, we're going to take examples of a term and its differentiation. Term and its differentiation. If the term, for example, is 5x, differentiation 5. If it is 3y, differentiation is 3 dy by dx. We call it 3y dash. If we differentiate 2x squared we get 4x. If we differentiate 4y squared, we get 8y y dash. If we differentiate xy, this is a product root. We leave the x, differentiate the y dash, then we write differentiate the first is 1 times the second is y. The same thing if I ask to differentiate x squared y squared. We can leave x squared and differentiate the y is 2y y dash. And then write differentiate the x squared 2x and leave the y squared as it is. What is the differentiation of e power y? Is e power y dash. What differentiation of ln y is 1 over y and y dash over y. And so on. What the differentiation of sine y is cosine y dash. Therefore, we take each term and we differentiate it. Then what are we going to do? The following example will tell us what are we going to do. We have the equation x cubed plus x plus y cubed plus 3y equals 6. And we wanted to get dy by dx. We differentiate each term. X cubed is 3x squared plus 1 plus 3y squared y dash plus 3y dash equal differentiation of a constant is 0. We collect terms of y dash on one side, y dash into 3y squared plus 3. The other side, negative 3x squared negative 1. Therefore, y dash equal negative 3x squared plus 1 divided by, can take 3 common factor, y squared plus 1. This time, the differentiation is a function of x and y. Not only x, no. The differentiation is a function of x and y. Let us have another example. Now, we are given this question. Find the value of dy by dx to find dy by dx at L point 1 and 1 when four x y squared plus 6 x squared over y equal 10. This equation has one part multiplication and one part division, so we do each one separately. Right, how to differentiate? We need to differentiate 4xy squared. Right, this is a product rule. We can differentiate 4x is 4 and leave the y squared as this. Then we leave the 4x as this and differentiate y squared to y dash. And the differentiation of 6x squared over y we can leave it like this, or you can say 6x squared times y power negative 1, as you like. Anyway, we need to differentiate. We need to say x equal u, the top u equals 6x squared and v equal y. يبقى u dash equal 12x and v dash equal y dash. Then the differentiation is v is y times u dash is 12x minus u is 6x squared times v dash, which is y dash, over the numerator y squared. If we substitute this in the equation up there, therefore we get 4y squared plus 8xy y dash plus 12xy minus 6x squared y dash over y squared equal differentiation of 10 is 0. We substitute x equal 1 and y equal 1. You have 4 plus 8y dash plus 12 minus 6y dash over 1 equals 0. This gives us, right, 2y dash equal negative 16, يبقى y dash equal negative 8, and this is the value. The next is when we have another rule of differentiation. Now, we know how to differentiate y equal e power x, but now we want to differentiate y equal a power x. Now, there are two ways to prove the rule. Anyway, the rule says dy by dx is a power x ln a. And there are two ways we can prove this. The first is if y equal a power x, we can change the base. And this is a rule given in the formula sheet. A power x equal e power x ln a. And this is written in the formula sheet. And therefore dy by dx equal e power x ln a times differentiation of the power is ln a. And e to the power x ln a is a power x ln a. The other proof is you write y equal a power x, and you take ln both sides, you say ln y equal x ln a. Then you differentiate this as an implicit equation. Differentiation of ln y is y there, and this is y dash, and differentiation of x ln a is ln a. يبقى y dash equal y ln a, and the y is a power x ln a. Whatever method you you would like to use to prove it, but this is the proof. Therefore, if y equal 5 power x, dy by dx equal 5 power x ln 5. If y equal 3 power x, dy by dx equal 3 power x ln 3, and so on. Very straightforward rule. Y equal e power x, it is e power x. But if 3 power x, it is 3 power x ln 3. Now, if y equal half to the power x, dy by dx equal half power x ln half. Now, one last thing we need to know in differentiation is something we call connected rates of change. Connected rates of change. What we mean by this? If, for example, A equal pi r square, and I have the rate of increase of r, and I want to get the rate of increase of A, then we use a chain rule, which say dA by dt equal dA by dr times dr by dt. Therefore, if it is given that dr by dt equal 5, and we are asked to find dA by dt when r equal 4, we say dA by dr equal differentiation 2 pi r. Therefore, dA by dt equal 2 pi r times the rate of change of r, which is 5. And we substitute r equal 4, 2 pi times 4 times 5, we get 40 pi. Another example. If we are given this, right, the volume of a hemisphere is 2 over 3 pi r cubed, and the surface area S is 3 pi r square. Right, we are given dV by dt equals 6. Want to find ds by dt. Here we cannot relate V directly with S, but we have R in between. Therefore, what we do is, from dV by dt we get dr by dt. So therefore we say dV by dt equal dV by dr times dr by dt. dv by dt equal dv by dr equal to 2 pi r square. Differentiation of 2 over 3 pi r cubed, 2 pi r square. This is dv by dr, okay? This is dv by dr. Therefore, dv by dt equal dv by dr times dr by dt. Well, given dv by dt is 6 equal 2 pi r square dr by dt. Therefore, the value of dr by dt equals 6 over 2 pi r square. Then we have a equal 3 pi r square. dA by dt equal dA by dr times dr by dt. We just substitute. dA by dr is 6 pi r times dr by dt, which is 6 over 2 pi r square. From this, we get 36 over 2, 18 over r. Therefore, we have dA by dt is 18 over r. Given the value of r, we can get dA by dt. Right. Now, this is the end of this first part, right, of the differentiation, and this is the end of differentiation. We took like 6 cases before in C3, and we had here 3 cases more. Therefore, this makes the total of the 9 ways or 9 types of problems of differentiation.